Hi ladies, in this video we're going to go through the applications of quadratics test. Okay, so only 3 questions and a bonus question, but they were quite challenging. And you need to remember that Mr. McClellan and I are exposing you to challenging questions because we are understanding that you want to go on to do maths methods. That's why you've chosen mainstream maths. And in methods, you're going to be exposed to questions that are challenging. They are probably different to what you have seen before. Okay, so especially when you get to the exam, because your teachers won't have seen the exams, and so they can't really prepare you. I mean, they can do their best, but they can't think, oh, this question's on there, and give you little hints. So you need to be exposed to questions that require you to actually think. Okay, so that's why we're doing it. So as a part of your assessment, you're given this. If you're concerned about your result, we're using mostly your result from the first test, but do keep in mind anything you do is a form of assessment, all right? So we need to check your understanding of content, but also your ability, I guess, to think critically about a question and think about, well, how can I go about solving this? And that's basically the purpose of these types of tests. All right, let's get started. So question 1, a tennis ball is projected vertically upwards into the air. So you can see here is the tennis ball going up, and then obviously it comes back down again because we don't live in space. Now, a lot of questions in quadratics and parabolas involve a ball because they are easy to write. Ball goes up, comes back down. Usually the flow of the ball is symmetrical, if that makes sense. So this middle point here, the time it takes to get to that middle point is the same as it takes to get down, and the distance is the same. Stuff like that is all consistent. So this won't be the first time you've seen a ball thrown in the air in maths. All right, so let's move on. All right, over time, t seconds, the height, h meters, is given by h equals t times 6 minus t. So this is your quadratic. Okay, so it's there. We're learning quadratics. If it doesn't look like a quadratic because it doesn't have a little 2, it's a quadratic function, because if we were to expand this, you'd get your t squared. All right, so first question, what is the height of the tennis ball above the ground after 1 second? So that just means we've got to let t equal 1. So if t equals 1, we're going to have h equals 1 times 6 minus 1. Okay, so all I've done is substituted in 1 wherever I see t. And that means h is equal to 1 times 6 minus 1, which is 5. So the height, and I'm going to try to write really neatly so I can use this later to give to you. Sorry, I just had a bit of a blank. I was about to write 5 seconds. It's 5 meters. All right, so that's the answer for question A, 1A. Calculate how long in seconds it takes for the ball to reach the ground again. So if you've got, and I might just go back to our diagram here. Here's your ground. Actually, let's do it in green because, it's grass. There's your ground. And this point, because we're at ground, is 0. So basically, we need to let h equal 0. Scroll, scroll, scroll. Let me just go back to pink. All right, so we're going to let h equal 0. So in our formula, we're going to have 0 equals t times 6 minus t. Okay, and if you scroll up, that's where I got the equation from. H equals t times 6 minus t. You're just letting h equal 0. All right, so we need to solve the t. So we can now split this. We can say, all right, that means either t equals 0, so using the null factor law, or 6 minus t equals 0. So I've already got my one solution. There it is there. 6 minus t. So if I take the t over to the other side, I'm going to get t equals 6. So basically, your tennis ball leaves the ground at t equals 0. and then comes back at 6. So it's kind of in the air for 6 seconds. Now, realistically, I don't know of a ball being up in the air for 6 seconds. That does seem like a relatively long time, but sometimes maths doesn't always make sense to us. So let's just write that down. So 6 seconds. Now notice how I've put my answers in squares here. I'm going to put this one in a square as well. Okay, because whoever is marking your test, and I'm not just saying this for my own benefit, girls, I'm thinking of your future. I'm not being lazy here. This is just to show the person who is marking your work where your answers are. So in the first one, it was quite obvious, but if you want, let's just be consistent. We'll put that in a square as well. When I was marking some of your tests, you were writing, you're giving me it in a sentence. I don't need a sentence. I just need the answer. Okay, so you're wasting time writing a sentence. I'm not saying I don't like it and there's anything wrong with it, but girls, when you go into methods, especially when you go into the exams at the end of year 12, you need all the time you can get. So don't waste time writing sentences. Just put your answer. Okay, and speaking of wasting time, I tend to waffle on, so let's move on. Question C, calculate what time or times the tennis ball reaches a height of 8 meters, sorry. So H equals 8. Oh my gosh, it's late, girls, sorry. H equals 8, so our height is equal to 8. So just like before, we let H equal 0. This time it's going to be 8. And we're just solving for T again. Okay, so what we need to do is expand this side here. So we've got 6 times t and then minus t squared. I'm going to put everything over this one side. Now, it's much easier if your t squared is positive, so I'm going to bring that over to the left-hand side. When I bring the 6t over, it's going to be minus 6t, and the 8 is already positive and equals to 0. Okay, so going to have to factorize this. That's an easy one to factorize. So two numbers when multiplied give you 8 and when added give you negative 6. So your two numbers are going to be negative 2 and negative 4. So no, I always do my quadratics this way. I'm sorry. I'm not really sorry. I'm sure you don't really care. But it's just easier to set up. Put your brackets, put your variable, and then you put your numbers. Okay, so null factor law, t minus 4 equals 0 or t minus 2 equals 0. So we're going to have t equals 4 and t equals 2. So your final answer is going to be at 2 seconds and 4 seconds. What I've got down the bottom here would have been fine for an answer. And the reason for that is because t is already defined as the time. Now, if you go on and use x instead, that's a huge mistake because x hasn't been defined as anything. The question is clearly says t, so stick with the variable. If you do go on to use x, you kind of need to do an answer like this. Otherwise, the x is meaningless. Okay, so you need to keep consistent with the variable. So we're working with t. What is the maximum height in meters that the ball reaches? Now, we haven't really done parabolas, but I have touched on that they are symmetrical. So that just means when your ball goes up and comes back down, and I'm sorry that's not very symmetrical, but this point here was 0 and this point here is 6. So that means your halfway point is where your maximum is. So halfway between 0 and 6 is 3. Now you could use any two values of t. So we could have used 2 and 4, okay? Because if we put 2 here and 4 here, and think of that, that's your horizontal scale or your t scale. Halfway point between 2 and 4 is also 3. Okay, so you can use any two x values to find that point. Okay, so the maximum occurs at t equals 3. So to get the height, we just substitute in t equals 3 into our equation. So we're going to have 3 times 3, h is equal to 9. Now, I did see some people just write 9. I don't know whether it was a guess, but you do need to actually show your working out. So if you wrote 9 with no working out, I probably didn't give you full marks. Okay, so always show your working. And also show your working even if you can't get to the final answer. I did give a lot of marks, even if you didn't get your final answer, because I like to see your maths. Okay, if I see your maths, I'm going to reward you for actually trying or getting part way there, even if you don't get the final answer. All right, question 2. A tiled path is placed around a swimming pool. The width of the pool is x meters. Okay, so this is x down here. Actually, I might draw it. So that's x. And the length of the pool is x plus 5, which is along here. Determine an expression for the area of the pool in terms of x. Okay, so we've got our length and our width. So the area of a rectangle is length times width. And all you need to do is substitute those two values in. So x times x plus 5. Now you could have left it in factorized form or you could have expanded it. I accepted both. All right, moving on to the next question. Show that the area of the path surrounding the pool is given by x squared plus 6x plus 14. So basically we've got the whole area. So I might just finish off the pool in pink. And just because it's a pool, let's do it a nice blue color. So there's your pool. Okay, wouldn't it be nice if it was nice warm weather and we could actually go for a swim? Okay, and then your path around the outside, we'll just do that in orange. There it is. I don't know what I'm coloring in, but sometimes I like to add a bit of color to these videos. Whoops. Okay, there we go. You get the gist. So basically this path, this orange section, is your whole rectangle around here, the outside. Okay, got that whole big rectangle and we're going to take away the pool and that leaves us with the orange section. So we're going to use the dimensions of the outside. So 2x plus 7 and x plus 2. 2x plus 7, and it's extremely important that you use brackets. And I've already forgotten what the other one was, x plus 2. And because we only want the area of the path, we then have to take away the area of the pool. And we did that before, x squared plus 5x. Now, a lot of you, I saw when you were doing the test, initially made the mistake of just leaving it like that. But if I left it like that, I'm only subtracting the x squared. I'm not actually subtracting that whole area. So always be careful, girls. You need to use your brackets. Okay, brackets are great. They're just like, you know, two big arms giving you a big hug. Now we'll expand these brackets. So 2x times x is 2x squared. 2x times 2 is 4x. Then we've got 7x and then plus 14. And I'm just going to make sure I did do that right. Sometimes I think ahead and I miss things. Okay. So we've already got the answer here. So if I don't get that final answer, I know I've made a mistake somewhere. So we've got 2x squared minus x squared is x squared. Then we'll bring our x-like terms together. So 4x plus 7x is 11x, minus 5x is 6x, which is good because I can see my 6x here. And then we've got the 14 by itself. Beautiful. And I've now shown. Okay, so that's all you had to do. This first part, the whole area minus your pool, expand it, and then you've got your area of the path. All right, question C, the area taken up by the pool and surrounding path is 65 meters. Show that the equation represented by this is 2x squared plus 11x minus 51. So this time we've got the area taken up by the pool and surrounding path. So we need this area here. We're not going to worry about taking away the pool because we're including the pool. Now I've already done partially part of that, so I'm just going to copy it down. So 2x squared plus 11x plus 14 equals, so it says 65. And it's just a matter of now bringing that 65 over. So I'll take away 65 from both sides. So we've got 2x squared plus 11x, and that's where the minus 51 comes from, equals 0. Okay, and that's all you had to do for that question. Now, the following one, question D, factorize and solve the equation from part C above to find the width and length of the path. So I'm going to have to copy it down. So we have 2x squared. I always read it, I'm like, I'm never going to forget 11 and 51. Okay. I always forget what they are. Now, you can factorize this as a non-monic quadratic. You can use a quadratic formula. Okay, so in my initial solutions, which I might also give you a copy of, I did both ways. I did, first of all, the quadratic formula, which is probably a little bit more time consuming than solving it as a non-monic. But I think for the benefit of this video, just because a non-monic is probably harder but also shorter, I'm going to do it that way. But you could use the quadratic formula also. Okay, so when solving a non-monic, we identify A, B, and C. So remember, A is your coefficient of x squared, B is your coefficient of x, and C is your constant. So we're going to do A times C. So we're going to have 2 times negative 51, and that gives you negative 102. Now we need to find two numbers when multiplied give us negative 102, and when added give us the coefficient of x, which is 11. Now the complicated part of this is thinking of the factors of negative 102. Okay, and I think it's quite time consuming to think of what they are, but you also can remember that the 11 kind of can guide you because the difference between the two numbers is 11. So obviously you wouldn't be picking two extreme numbers, like you wouldn't be picking 1 and 102 because obviously they don't add up to 11. But after a while you'll get it, and it can be quite time consuming, but you'll be able to, I think, do this a lot easier than the quadratic formula. All right, having said that, I did have to pause so I could think about it. So 17 times 6 gives you 102. Now, I'm going to put those two numbers here. Remember, they have to add up to 11. So this 6 is your negative. So one of the numbers had to be a negative because they multiply to give you negative 102. So I decided, well, this is positive, so that means your larger number is positive and your smaller number is negative. Okay, so let's keep going. So we've got 2x squared. Instead of 11x, we're going to rewrite that as 17x minus 6x minus 51. And then we factorize by grouping. So we group these first two terms and then the second two terms. So we take out the common factor. So the first one we're going to have x, and then we're going to have 2x plus 17. And for the next one, we're going to have, we're going to have negative 3, 2x plus 17. Now, if you're unsure about what the common factor is, use this bracket to help you. Okay, so The 6x, we want a common factor, so we get 2x here. So that's what the grouping is. These two brackets have to be the same. And then the 17 goes into 51 3 times. So 3 is your common factor. That made it a little bit harder as well. Okay, so we've got x minus 3 as our first bracket, and then 2x plus 17. Doesn't matter what order you do that in. And then we use the null factor law. So we're just going to separate our two brackets. So we're going to have x equals 3 and x equals negative 17 over 2. Now, we can't have a negative length, so we can only have one solution, which is x equals 3. Now, let's just go back and answer the question. So if you got to this point, that is awesome. Okay, that's probably getting you most of the marks, but make sure you read the whole question. You had to find the width and length of the path. Now, this question here, some people did this as the width, okay, just going around, but it actually meant this outside part. So 2x plus 7 and x plus 2. Let's just scroll down. Oops, gone too far, sorry. So we had 2x plus 7 and x plus 2 as our dimension, so we can call that length and this one width. Doesn't matter if it was around the other way. We just substitute x equals 3, so 2 times 3 plus 7. So 2 times 3 is 6 plus 7 is 13. And then the next one we're going to have 3 plus 2, which, see, I think ahead. I already wrote the answer. 3 plus 2 is 5. Okay, let's scroll on. Okay, question number 3. So this was quite a tricky one. These sorts of questions always come up as well, though, because they with this existing fence, it just makes for a good question. Don't ask me why. This complicates things a little bit, but you'll probably see this question again in the future. So a farmer has 60 metres of fencing with which to construct 3 sides of a rectangular paddock connecting to an existing fence. Show that the area in metres squared enclosed by the fence is given by A equals 60x minus 2x squared. Okay, so the important information it gave you was that the perimeter is 60. Now the perimeter here is going to be 2x, okay, plus this length here. So, and that's going to equal to 60. So to get your L, we're just going to have to take this 2x over to the right-hand side. And now we've got the length in terms of x, and your width is already in terms of x. So your area, which is length times width, we just substitute these values in now. So we've got x times 60 minus 2x. Again, it doesn't matter on the order. I just put it that way because it always looks weird if you put the x on the end, but it's the same thing. Multiply the x in, so we've got 6x minus 2x squared. Okay, and that's how you show that formula. The area of the paddock is 200 metres. Find the width and length of the block. So we've got 60x minus 2x squared equals 200. So let's put everything over to the same side. Again, we want to keep the x squared coefficient positive. So I'm going to do 2x squared minus 60x plus 200 equals 0. Now at this point, I can take out a common factor of 2. So if I took out a common factor of 2, you don't have to write it like this, but I'm just going to show you why that 2 disappears. So if I divide both sides now by 2, that goes, and 0 divided by 2 is still 0. So you're still left with x squared minus 30x plus 100. Now you have to solve this using the quadratic formula. It's just the easiest way. Actually, you probably complete the square as well, but I always think the quadratic formula makes it a little bit easier. I actually haven't done this by completing the square, but you can't just think of two numbers when multiplied give you 100 and when added give you -30 because you're dealing with surds. All right, so let's identify A, B, and C. So I'm going to do the quadratic formula. Now your quadratic formula, I always like to write it down because it means, you know, I remember it now after, you know, always teaching Year 10 maths. I remember it. No, so the more you write it, the more you're going to remember, but usually formulas like this are given to you on a formula sheet anyway. All right, now it's a straight substitution. I'm sorry, we've run out of room, so I'm going to have to just go under the end of test. So x equals, now b is already negative, so it's going to be +30 plus or minus square root b squared, so 30 squared, or it's -30 squared, but when you square a negative number, you get a positive answer. So it's the same as 30 squared, which is 900, minus 4 times a, which is 1. So I'm not going to write the 1, I'll write the 1 there. Times c is 100. Okay, and that's over 2a, so it's 2 times 1. So it's just going to be over 2. But I'll write 2 times 1 just in case you wonder why it's just 2. Okay, so let's tidy things up a little bit. This is where it gets complicated, but if you take your time, you should be fine. I'm going to do this all in one go. So 4 times 1 times 100 is 400. So 900 minus 400 is 500. And then we've got that over 2. This can simplify as a surd. So I might do this over here. Oh, sorry, just cross it out. X equals, not x plus, x equals 30 plus or minus. Now, we've just done surds, so hopefully you remembered how to simplify this. This becomes 5 times 100, so it's going to come out as 10 root 5 over 2. Now that 2 can divide through the 30 and the 10, so we're going to have x equals 30 divided by 2 is 15, and 10 divided by 2 is 5. Okay, so there's our solution. So this obviously separates to two solutions. So we can have x equals 15 plus 5 root 5. And we can have x equals 15 minus 5 root 5. Now, the thing is that 5 root 5 is actually less than 15. So both these answers actually need to be considered. Okay, so you need to consider this first one and the second one. Now, just because I've run out of room, I'm just going to show you one of the solutions, but you do the same thing for the other one. So I'm going to choose this one here just because it gives us, I don't know why I choose it. It's a plus. It doesn't matter which one I use, but I'm going to use that value of x. This one here, initially I thought it was going to be negative, but the way you can always think about it, the square root of 5, you probably don't know what that is, but you know the square root of 4 is 2. So it's going to be 2 point something. So it's going to be 5 times 2 point something, which is always going to be less than 15 because it's not quite 3. If it was 3, so if it was something bigger than the square root of 9, then yes, it would be a negative. But at this stage, it's going to be a positive. If that doesn't make sense, just ask me what I'm talking about. Okay, so let's go back. So the length of x, we've already done. Now we've got to do the other side, this length here. So that is 60 minus 2x. So let's just do that down here. So our width is 15 plus 5 root 5. Our length, remember, is 60 minus 2x. So just because I'm short on time, on space, I'm going to do that there. And you can leave it like that. It's probably a little bit nicer to tidy up. So eventually when you move into methods, you would probably have to expand that. So let's do that. So minus 30, and then 2 minus 10 root 5. So we're going to have 60 minus 30, which is 30 minus 10 root 5. Okay, so there's our two solutions. So I'm going to put a nice square around that. And there's our other, so our width and our length. All right, I can't keep scrolling to get the bonus question, so I'm sorry that's not there. If you just want the answer, oh my gosh, what was it? I think it was 9 and 37, or was it 7 and 39? I think it was 7 and 39 were your answers for the mum and daughter question at the end. All right, girls, bye.